few questions that might be asked. So it's way beyond what one AP question. But it should cover all the bases, I hope. Let's see. First and foremost, this is a calculator question. So would you get out your calculator and throw velocity in, please? And anytime they give you a window, you should use it. So in this case, they say this only is applicable from 0 to 3. So set your windows 0 to 3 in X. And I will get this in myself. I don't remember what it was. I think it was X plus 1. And what was the rest of it? Sine of t squared. Oops, there it is. Boom. You got something like that going on? Wait. In terms of the scope of this whole problem, I don't know if I do this on an AP question until I pre-read all the parts, but I think you'll need lots of stuff going on. So would you find me, I don't know if we'll need all of it, but would you find me that, I'm going to call that A. Store that to A, B, C, D, E. The max, just going left to right, the maxes, the mins, and the zeros. So A, max, B, 0, C, min, D, 0, and E, max. Again, find all those, store them to A, B, C, D, and E, por favor. If you do not remember how to store, let me know. Oops. Oh, can you just do like the whole window and find all the zeros at once? If I just set a huge window, will it find both? No. That's dumb.
I agree.
Why don't they just... I thought it did. Darn it, I keep... You just need the X's. I don't think you need the Y's. D. Are you having a lovely day? Sorry, this is you guys are young. You're supposed to be able to multitask. Are you having a lovely day? Oh, good. Glad to hear it. Seniors, you got to live up this homecoming week, right? As much as you might think, oh, it's kid stuff, I would be glad to be done with it. You're going to miss it. It's not often you get to wear your jammies to school or whatever. Sorry about that.
Can't you do that every day?
Oh, you got me there. But it's not a community. It's not No, I take it back. Everybody's wearing their jammies. You got me there, I guess so. But when you work, you can't just wear your jammies. Oh, wait, that's not right. I did that wrong. Okay. Yeah, Sharon story, let me know. You should have 5 swords. Yes? Okay. I don't actually know if you're going to need all 5. I think you do. I can't remember. All right. Once you get that done, then normally on an AP problem, when you do that, if you intend to recall or reuse that same value over and over again, if you mark up your picture saying, here's that point, and I'm going to call it A from now on, then that saves you some time on the AP test, as long as your variables have been clearly defined. So this, I don't know if this problem would be of that nature. It's usually more of a volume problem where you do that. But I'm going to identify each of these on my picture. So that first, which was A, what was that one? What was that value? The lowest one was 1.772, is that correct? 1.772, x equals 1.772. I am going to herefore refer to as A. This point, x equal, oh, is that this point?
It was 1.317.
Did I find these wrong, or did you have 1.772 somewhere?
Yeah, that was
Oh,
0.
okay, 1.3, what is it again? 1.7, that's A. 1.772, that's B. X equal, what was that one? Maybe 2.187, okay, is C. The next one is 2.506. Give me 3 decimals rounded or truncated. 2.506 is D. And I think there was a last max there of x equal 2.8 or something like that, wasn't it? 811. Okay. Is E. All right. Oh, that's cool. Now we can just call them stuff like that. We're going to need those in a minute. All right. Question A then. Find the acceleration of the particle at time 2. Now this is calculator active, so it is not the intention that you will take the derivative by hand, although I'm sure you could. Product rule and all that stuff. That is not the expectation. They don't give you a point for taking the derivative by hand, but if you do take it by hand and screw it up, they will absolutely take off. So it's kind of expected that you use your calculator. You do want to label your work. So A at 2 would not be enough. You would need to communicate what is it? What's the calculus relationship? Okay, so you would want to say something like A at 2 is B prime at 2, and that's this by virtue of the calculator. So find the derivative at 2, please. Shift. The integral shortcut is so much better than the derivative keyboard shortcut, isn't it? There's a derivative shortcut, isn't there? Shift minus or something? But is it handy? I don't think it's very handy. So I want the derivative at 2, yeah? Of the function, which I think I only have one in there. So did you get something like that? Okay, so reporting our, they didn't have units in here, but I tried to get units in here just to get to the practice. So it's negative 8.60, what was it? 1. Given that the original velocity was in units per second, it's going along the number line, then what are the acceleration units? Units per second, or units per second squared, right? Okay, now that first question was a softie, get you going. The second one is very frequently missed, and that's actually a whole focus of this worksheet. Speed is increasing or decreasing at time equal to. Can I say, hey, looky there, acceleration is negative, so speed is decreasing? No, you say no, why not? Okay, so this person is thinking velocity, not speed, right? Because the derivative of velocity is negative, it would be logical to conclude that the velocity is decreasing. Is it true that the velocity is decreasing at time t?
Yes.
Yes, it is, okay. But speed and velocity are not the same. So, question then. If that's a no, then how do I answer the question, speed is increasing if, or decreasing if, in an AP calculus, not physics, calculus way? If, oh, beautiful. Okay, velocity and acceleration have the same sign, okay? Now, let's just sort of clear this, gets deeply in your brain. Think about it this way. Say, this is the number line, okay? So that's positive side, this is negative side, right? Mm-hmm. All right. So, Jack, come on up here. Okay, so Jack is going to be doing the moving, and is your parent a lawyer? No. Okay, good. All right, so Jack is going to be doing the moving, and I am going to be the acceleration factor, all right? So, say Jack is moving that way. He's moving in a positive direction, and therefore his velocity is positive. So if he's, come over here, so I can really push you. Okay.
Okay.
Okay, go that way. And I'm accelerating. Now what happened to his speed then? It increased. He went faster, right? So it seems like if velocity is positive and acceleration is positive, he speeds up. What if he's going that way and I push that way? Then his speed will slow down. He'll decrease. What if he's going that way and I only push you one more time just for a second. So if he's going that way and I accelerate him that way, then speeds up. Okay, thank you. So well done. Yeah. Give the man a hand. All right. All right. So the idea is if they work together, then the velocity and the acceleration start to speed up. So speed is increasing if the velocity and acceleration have the same sign. And that is the expectation on the AP Calculus test for the justification. And it's decreasing if velocity and acceleration have opposite signs. So to answer the question, it's not enough to just say, boom, boom, there's A at 2. I also need V at 2. I can't say if they're the same or different signs until I have both signs. So I need V at 2. So go to your calculator, hit V at 2. I get negative 2.270. How about you? Okay. So in this case, V at 2 is negative 2.270. That's, and the units are units per second, that's enough for me to then answer the question with justification. I would say the speed is increasing. I would say speed is increasing at time 2 seconds because, what? Velocity and acceleration have the same sign. You follow? Okay, going to another idea. Yep. You don't. You do not. If it says find these numbers, there's a question like that where you do, but not. That's a good question. You surely have to have the evidence and record, but after that you can just make the conclusion without bringing them in. Part B, find all times in the open interval where the particle changes directions. I'll let you do that. You should probably be able to figure that out on your own. And then we'll go, we actually have everything we need. Write it up and then we'll talk about that one in 30 seconds. You may use the letters instead of giving the numbers, just to save some time. So, particle changes direction at times what? D and D, because velocity changes signs. Okay, good deal. Total distance traveled by the particle on 0 to 3. Try that, and we'll go over it in a minute. That's a shortcut for integration on Inspire. Shift plus, right? Shift plus, if you do shift plus, it gives you the integral. Just, yeah. What do you say, 1.729? You don't say that, okay? Why is what I did not okay? It's displacement. It's allowing for positive and negative movement, and really I'm just getting the net change in all the distances, or the net difference between all the distances. That's not what I want. So I should actually be showing the integration of from 0 to 3 of absolute value, saying I don't care about direction. I just want to remove the direction component and total up how much total movement. Notice, in terms of Calc 2 preparation, that when you integrate speed, you get distance. And when you integrate velocity, you get displacement. Now that's important because in Calc 1 we do rectilinear movement, which is to say one-dimensional, okay, along a number line. But in Calc 2 you do two-dimensional movement, and in Calc 3 three-dimensional movement. So it's a little more complicated in terms of that, but if this idea stays the same, integrate speed, you get distance, even in two dimensions. And velocity is displacement. So we know that this gives distance, v, and this gives displacement, v. A little bit of a corollary, though. This is a gotcha problem on the AP where they'll throw this at you and people lose points here. In cases where the velocity is positive on the interval, then how do the two relate? They're the same. Distance equals displacement, and it's the expectation that you should give or say both. Now I'll come back to that. There's a problem like that in here. When you throw absolute value on then to guarantee distance, what's the distance in C? Did you say 4.567?
658.
658, 657. What are the units? That's units, okay? That's units. This is units per second times seconds. That's units, right? Right, Mr. Rickman, thank you. D, find and interpret that bad boy, please. Would you find and interpret? Now, this is a case where they're asking you to find a number and then interpret. So it's the expectation that you use your number in your explanation. I should have actually said interpret your answer in the context of the problem is how it would be worded on the AP test. That corner. Interpret your answer in the context of the problem. So let's talk about explanation. Find and interpret 1.6315. You would say? Displacement, okay. Displacement is 1.6315. So you're going high physics on me, and that's to be expected. You have good physics. In terms of right-left movement, talk to me about what's going on. At time 0, or sorry, at time 2 seconds, the particle is 1.6315 units right of where it was, or position at time 0. You could say the displacement of the particle is 1.6315 units, and especially in a college setting, they would be very receptive to that. The AP is kind of anti-physics in the way they grade, I gotta say, and so you got to be careful not to overdo the physics as much as you have awesome physics knowledge. Try E. You might think it's the same, but it is not. Well, at least it would be graded differently or harshly. This goes to something I lost points on until I got used to the AP grade. I did this as answer 0.540, right? Okay. At time equal 1 second, the particle is 0.540 units right at position at time 0. Now, the way this would be graded in the AP test, I would get 1 out of 2. The expectation is that if, here's 1 over here. I don't know what's my scale here. Anyway, 1's over here, right? Oh, what happened there? Anyway, what do you notice about the velocity in that region? It's always positive. And so the expectation is that besides displacement, it's also distance. And they would want to say something like, because the velocity is positive on 0 to 1, this is also the distance traveled. This part is the part that communicates to the reader that you're not some knucklehead who thinks integrating position is always, or velocity is always distance. It's just in this case, it's distance. Right? You with me? All right. How about, yes, sorry. Go ahead. Oh, yes.
Would they, like, your answer if you said that, that's the displacement from time to equal 0 seconds to time to equals 2 seconds?
Problem is that you're not really interpreting the sign, so I don't know. Let me ask Mrs. Lowe, and I'll get back to you. I'm not sure. It is truly displacement. That's, I mean, there's no getting around it. It's a fact, but they're so picky about, I don't know. It's good enough. It's fine. I'm not going to sweat. They're picky. Are we good? Can I move on? Okay. F. In this case, the function is not easily integrated. I think you'll agree. So that then means that we're going to give an expression involving an integral for position and time. To give that a shot, I did give you an initial position way back up. Not to say that you should be using it. I don't help here. Oh man, it's on the back. Sorry, I hate when you have to flip back and forth. My bad. All right, so give me position at time t, whatever you called it. I don't know, what'd you call it? X is horizontal movement, so it'd be logical to call it x. Or whatever you want to call it. What is it? -1 plus to t of v of, now if you used x here, then you wouldn't use that again, but I assume if you're saying x, you didn't call, what did you call position? H? H? That doesn't make any sense. It's horizontal movement. Oh, H for horizontal. You just, no, you used height because you thought of height. Don't tell me you said horizontal. That's crazy. I don't buy it. I think you're thinking this is a height function. I really do. X makes all the sense.
Yeah, I like
It's
to.
a number. YP?
Yeah.
Position.
Or pecan ice cream.
Both are delightful. I think that was all we had to do. Are we clear where we're going on there? Okay. What's the greatest distance between the particle and the origin? Keep in mind, is this relative max or absolute max? Absolute max. Okay, so going in an absolute max kind of way. Absolute max what? Distance? It's really the absolute max. Here's why I bet you wish you used x. You want the absolute max. What's farthest from the origin? I take it back. I'll go back. Go back to pre-algebra with you. What do we call distance from the origin? No, we don't. We call it, you use displacement in pre-algebra? Okay. Distance from the origin is called absolute value. Okay, we want the greatest. What do you mean great? See, because your teacher said this is what absolute value means. It's the distance from the origin. You said, so it means always positive, right? And that's what you boiled it down to, because you didn't listen. It's distance from the origin is what absolute value is. It's distance, so it's always supposed to be positive. Wieners. All right, so at any rate, I'll let you work it out. You think about it. I just threw the absolute value in at the end. Really, it's the greatest x without respect to sign, or greatest position without respect to sign. Yeah? Okay, go. You could even say it's either an absolute max or a min position, right? Do I want to use velocity or absolute value of velocity? Absolute value. What? Do I want to make all the movements positive, or do I want an accurate picture of when it's moving backwards or forwards? Am I confusing you or confusing me? You don't want to use absolute value because you want it to account for negative and positive velocities, right? Did you get 0.729 for position at time 3? Okay, so we're on the same page, despite your overboard silence. Okay, how are we doing? What did you argue the greatest distance from the origin was? Or does it say what is the greatest distance or when is the greatest distance? What? Okay, so we conclude the greatest distance from the origin is... I got 0.89. Oh, negative 1. Poof. Is 1, right? 1. Isn't that the greatest in absolute value of all those numbers? Okay, it's the furthest away from the origin when it's at negative 1. So that's the greatest distance is 1 because, now here's what I need to figure out how to do this. Isn't it really the absolute values I'm comparing here? So I really need to say something more like the absolute value of negative 0.569 is less than the absolute value of 0.729 is less than the absolute value of 0.894, and that's less than the absolute value. Or its distance, its absolute value or distance from the origin is greatest. You follow? You're a real quiet bunch today. I hope you're pensive, not sleeping. H, what is the particle moving toward the origin on the interval? Common mistake, can I just say V is negative? Oh, actually, I don't want to say common mistake. If you think that's good, do that. Then write it real light because you're going to be erasing it. You know what? Maybe we should... I don't want you to integrate the whole... To answer this question, I need the whole position function, right? Can I make a small modification just for your benefit? Is the particle moving towards the origin or away at time equal 2.6? Justified. Are we ready to talk about this? Okay. Is it enough to just say V at 2.6 is 1.652, so it's moving away from the origin because its position is increasing. Something like this. You with me? Okay, why isn't that enough? What else do you have to take? No? Position. Okay, imagine if you're here on the number line and your velocity is positive. Then how are you moving? Towards the origin or away? Towards. Imagine if you're here and velocity is positive. Then are you moving towards the origin or away? Away. Okay, so it's relative to where you're at and whether you're moving right or left. So you need position also. We. What is position at time 2.6? Somebody that knew to do that? Negative 0.492. It sounds like all of you need to do that. Man, you're smart. So based on that, it's at a negative position and velocity is positive. So how do you want to say this? This is something I get stuck on. So how do I say it? What'd you say? Is it, first of all, let's answer the question. Is it moving towards the origin or away? Okay, so the particle is moving toward the origin because, why do you say that?
You should just say because position and velocity are opposite signs.
Yeah, I suppose so. I was thinking of it as getting fancy. I guess that makes sense. Because you're at a negative position and you're moving right. Yeah, I guess so. Good call. Is that how you do it in physics? Or are you just smart?
Physics.
You don't do this in physics? Oh, cool. Okay, have opposite signs. That is true, and that would absolutely be the case. If you wanted to kind of do it in a more thinking it through kind of way, it's just because it's at a negative. It's left of 0 in the number line and moving right. That would also say, right? Okay. And then how many times, if any, is the particle at the origin? Justify your answer. Let's go back to this here. Okay? In terms of time frame, at time 0, it was at -1. And then at time B, it was at positive 0.894. And then at time D, it was at negative 0.569. And at time 3, it was at 0.729. So what do you say about this then? How many times, if any, is the particle doing? Okay, so at least, you say at least 1, 2, 3. Okay, at least 3 times? You're close. Anybody have a slightly different? You're off. It is not at least 3 times. It is exactly 3 times. Not at least. Why? How is it moving? Okay, this might be a bit of vocabulary. From here to here. Huh, that's fun. From time 0 to time B. How is it moving? In a rightward direction. Okay? Only rightward direction the whole time? Yes, exactly. Now you would say that's moving monotonically. Okay? The derivative has one sign here. And so because the derivative is monotonic, it has exactly one. It doesn't, pass through a few times. It passes exactly once. And so you would probably, at least in the college setting, you'd probably lose a little points there because it's not at least 3 times. It's exactly 3 times. And you would say it with the IVT. Could you... So you guys are pretty good at the IVT, so we can maybe spare the whole write-up so we can move on. But you would say exactly 3 times. Do you want to go over that? Or are you with me? Okay. Exactly. Let's first answer the question and talk the justification. In order for IVT to apply, the condition is continuity. Continuity of V or P? P. Okay. We're claiming its position is continuous from one to the other. Position is continuous. And so we could say we need to then identify some times where it's going to be 0. We would say P equals 0 once in what time interval? The interval from time 0 to B, because position of 0 would be between, I would say it this way, position at, what was position at 0? -1? Okay, because position equals 0 between -1, where it was at 0, and positive, what the heck, what is it? What's position at B? You see what I'm saying? It went from -1 to 0.894.
Yep.
So it has to have passed through 0. Okay, so P must have been 0 once in that time interval, because P equals 0 is between -1 and 0.894. And I might say, at some point in our IVT, you need to say it somewhere in there. I probably could have put it up front, maybe by IVT, there are, blah, blah. Again, P equals 0 once in B to D, because P at D is a negative value of something, and P at B is 0.894. You follow? And position equals 0 once in what time interval? D to 3? Okay. Because at D it was negative, and at 3 it was a positive position. 3 times. Now, to really cover your butt, you would say P equals 0 once in 0 to B because something like because V is monotonic on 0 to B and blah, 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 blah. That would be like perfect. Okay. That's saying why it has exactly 1 each time, not at least. You follow? Monotonic means the derivative is 1 side. Okay. Well, I'm exhausted. That was really fun.
Why is it?
What? Oh, sorry.
Why is it consecutive?
Because, so let me say this. This is the velocity function, so keep that in mind. But if I overlay the positions on top of these, the particle is at -1 at this point. And as it moves right, it eventually, at this point, ends up at 0.894. It moves right that whole time. So in terms of going from -1 to 0.894, it passed through 0 exactly once, not more than once. It didn't go back and forth through 0 a couple of times. It went exactly once in this interval. Because the velocity is positive for that whole interval, it was moving right that whole time. And so if you move right the whole time, you can only pass through 0 once. The only way you can pass through 0 a couple of times is you go back and forth at the interval, right? Likewise, because velocity is only negative in this interval, it only passes through 0 once in that interval. And because velocity is positive only on that interval, only once on that interval. Yes?
And do you have to state IVT?
At some point in there, I kind of tacked it on somewhere, but you should say IVT in there better than I did. You should, yes.
So do you have on the answer you're going to write out all of the values, or can you just say equals 0 3 times?
It depends on if you want credit on the AP. So if you want credit, then yes. But if you don't want credit, then I guess my opinion would be just leave it blank altogether and wish you fine. If you're not going to go for the points, then just move on. Yes.
You have to see that, that loss of monetary on your B and P2.
You should do it well, yes. Okay, now that would be a question at like a high level. You go to the University of Chicago and they're trying to separate the great from the greatest, that's where they're trying to divine who's amazing and who's just awesome. But that's not the question. Yes?
Does it matter like if it's open or closed?
Good question. I didn't even think about that. I lost so many points in college because I didn't think of the end points. I can't even tell you. You tell me. What do you think? Once in, I think because it's not actually at 0, 0 at the end points, it's okay to go over. But I think closed would also be fine. Okay? Well, I don't know how to get caught up in this class. I really don't. There's so much to teach you when I give you this homework and how's homework going? What about 74? Yay! No? 3? Most people turn in 73. Give me 73. 23 on 74. Okay. 74 number 23 is a business calculus problem. It's really quite famous. It's pretty complicated.
Also on that supplemental one down at the bottom, like after 25.
Okay, 10-4, good buddy. All right, so let's go here. Revenue. When you sell one thing, it depends on how much you collect, depends on the price of each and the quantity you sell, yes? Okay. Now, the point of this problem is that the quantity you sell is a function. So I actually want to sub for Q. Okay? You want it to be a 2 variable only instead of 3 variable problem. So sub for Q. They tell you when the price is 100 cents that you sell 1,000. And if you jack up the price 20 cents, you lose 100 sales. Why would you jack up the price if you lose 100 sales? Because you make more per. Now there's a trade-off there. There's a play. And there is a point where surely I think we can agree that if we jack up the price too much, then nobody's going to buy it and we'll make nothing. But there is a sweet spot in there where you manipulate the price just enough where price maximizes revenue. That's the big question. I could give you some. Can we get out of here in 5 minutes or now? I'll finish tomorrow. I want to do it well. This is important. We'll get caught up. Someday we'll get caught up. Tomorrow. Oh, man, look. Oh, well, that's... Factory? You said factory. Oh, extra class. I just said factory. Glad you're not too good.
Probably all of that.
That's a buddy.
Answer that for me.
That's Wilson.
Yeah.
All right. Have a great day. Good old Abby. I think she's
She's so sweet.
she's the best. And she's super smart.
She is super smart.
Yeah.